Hey everyone, welcome to the Antminer repair channel, and tonight we're going to replace a chip, but not on this board. This literally happened last night. In the middle of the night, this guy decided to just fry, and man did it smell bad, and it's got pretty hot. There's actually a hole in the circuit board right here you can push your finger through, so all I gotta say is be careful out there. Um, Don't burn your house down. So yeah, this got hot too. It can take the. Yeah. Anyway, I'll work on this. There's probably chips to salvage here, but if they're the kind that don't have a top you can solder on, I can't use them. But anyway, I want to show you that before I get going. So tonight on this video, what we're going to do, I've got this board I've been working on, obviously all over the place. I'll go through how I diagnosed this chip being bad. So I've got a brand new BM1397 chip here. No, it was not one. It was not one I fixed before. I never touched that board because I keep track of every board I fix, and I check that first. Frankly, what I think happened was a heat sink fell off, maybe. So two things might have happened. A heat sink fell off, and then it got hot, and then the chip smoked itself, then shorted the whole board. Or the boost circuit, which is right up here that carries a lot of voltage. Maybe it traveled up this way and then traveled down this way on that board. So, yeah, kind of scary and really smells bad where my miners are. So I'm starting to get a little better, but kind of get shaky. And I'm glad I didn't start a fire anyway. So my title is not accurate. Sorry about that. I can't change it now because I tried starting YouTube with the right title and it didn't do it, so I clicked start again and it switched the title back to the last live chat. So keep in mind we're not doing Picket tonight. That was another live broadcast. I will change the title soon as this gets published. Tonight we're changing a chip. So, all right. So this all started when let me do my standard disclaimer. If you're into fixing boards or trying to get boards fixed and learning how, check out the video description. There's a link to our Discord channel. We have over 700 people, maybe nearing 800 people on the Discord channel. So there's a lot of people, and a lot of people know what they're doing on there. So you can ask about fixing your thing, and usually somebody will have a statement, or what solder do I use, or how do you get off a heat sink and stuff like that. So that's a better place to ask me questions than on YouTube, because we could actually have a conversation about it back and forth, and I can post you links to stuff or videos I've already done and things like that. So go to the Discord. And then the other thing is I really don't ask any money for doing this, although there is on my videos I posted some address if you want to donate. But the best way you can help me pay for all this stuff, we're really close to get monetized on YouTube. I need about 1,000 more hours and about 150 more subscribers. So and I look on my analytics, and like 70 or 60% of you that are watching this aren't subscribed. So please subscribe, and that'll help me out. Okay. And then when I'm doing these things. I've been trying to do more and more live videos so people can ask me questions. Okay, so this board has been a problem board for a long time, kind of been all over. It's a pretty rough board. A lot of the chips don't have their tops on them. Basically, let me see, someone just did Discord. I want to make sure everyone's got that. Gosber, thanks. He's got eyes. So, all right. So one of the problems, I've had other problems with the board. They're like all over the place. This was board 5 when I labeled them this way. Now I track them by serial number. I got down to looking at, and I know this is glaring. Let me see if I can switch the glare. I got a light off the side. So kinda. I'll go this route. So I went to looking at this side of chips. I was getting 0 ASICs, so I basically was going through the whole board to figure out who has the short. And so I was using, I checked everybody using my voltmeter on diode resistance and on resistance. And then I went back and started testing. So you know there's like 3 power circuits here and 2 power circuits on this side. So each side of the chip, there's actually 5 more lines that have to go through those chips. So, you know, this won't have the right reading because the chip's out, but when the chip was here, I started looking at the resistance on these 2 small capacitors. And those of you with T17s, you have those 2 small capacitors. They're just somewhere else. But so I started testing the resistance on these, and one's supposed to be about 1.5, 1.6, or 1.7 ohms. And the other one's supposed to be like, it could be 70, it could be 300. That doesn't matter. It just has to be a lot of ohms. So I went through here and I was testing this chip, and the power was lousy. Because I noticed that when the clock went through here, it shut off. But on the S17, if the clock, which is this thing going through, I tested this, and the power didn't get past here, you'd normally think this was a bad board or a bad chip. Well, that's not necessarily true on this. You have to check if it's because it's not getting the power on the side. This power complements the power coming in and keeps it at 1.8 and 0.9 going through the whole system. And those are done through these guys. And these guys follow the track over to these guys, who follow over the track to these guys. And they have the same 2 resistors on this end of the board that you can check the resistance. So if you find a bad resistance, it could be here, or it could be there, or it could be something going on in the middle. And it's really difficult to find. So these 2 capacitors, I'm going to save my chip back so I don't lose it. These 2 capacitors come from these 2 LDOs. One's a 0.8 and one's a 1.8 LDO. And so these 2 guys go in here and they power not only some parts of the actual test ports, but then they wrap around and actually power some of these capacitors that go along this line. And other places, I think right here there's actually a break, and there's some middle logic with capacitors that actually power and reintroduce power here. So there's like a voltage segment for here, for there, and then I think in between here. So it's probably this chip. So 2 of these run on that. So anyway, I kind of had to make a decision on which one to pull. Basically, everything checked out on them, except I knew one of these 3 chips had a bad resistance here. So I knew one was bad. And I checked the diode resistance, and indeed I verified it was also. But it could be that this guy is bad here, and they're all connected to each other, so it could have just warped everything. So what I did is, frankly, I guessed. And I guessed right this time, because once I pulled this chip off and I test this resistance on these capacitors, they're pretty much in line. In fact, I'll do that, show you kind of what if I can reach them around here just a second. This guy normally would be about 1.5, it's 2.2, but that's okay because we're missing a chip. It'll probably go down. It could be off some. But that guy used to be really high. And I was moving around, so don't trust what you see. And then the higher guy right here can be just high. So really from what I've seen on working boards, those resistances are okay. When the chip was in here, those were not okay at all. So I pulled the right chip. So tonight we're going to replace that chip and go through the process. And let me, hey, good. Oh, good, Brian. Yeah, thanks. I appreciate it, Brian. Brian said my T17s are finally in. Got to get them cleaned. Be careful cleaning them with a high pressure air compressor. It might blow solder balls into them. So be careful with that. I don't use high compressed air. Really wiping them down with the rag as best you can, and some light air is the best. I've actually got new miners that tested good, and I went out with my air compressor and had 90-pound air, and had to fix them after that. So be careful with that. Okay, So tonight I'll go through the steps. We're gonna prepare this pad. I lost a resistor pulling this off, so we're gonna need to put a resistor on there. That's no big deal. I always do it kind of messy, but we'll get that on probably tonight too. So we're gonna prepare this pad. Usually this has lead-free solder, so we're gonna. I think I've been here before, to tell you the truth. I can see some of my patchwork, so I know this is leaded solder, so I'm just going to clean it up a little bit and reposition it. So we won't do the full solder remove. I will remove it off the center though, because there's solder there and I don't want it to build up the center of the chip when I put it into it. So then the next thing we're going to do is I'm going to take this new chip. I'm going to use the stencil. We're going to put some new solder paste on. And for those of you guys who haven't done this, you can ask me all about that. When I first got it, I was really lousy at it, and I messed it up. Still, once in a while, I mess it up, but generally, I get it pretty accurate with what it needs to be to put a new chip on. And I'm getting pretty good. All the times I do it on video, at least it works. It's the times you aren't on it doesn't work. So we're going to do that. And so then when I have the board and the chip ready, I'm going to show you how to place it. I'm going to put a little bit of tiny flux here. And then over here, where you can't see up above my hand, I've got a rework station with a hot plate. We're going to heat that board up, and with a chip on it, and we're going to wait till it gets up to about 150 degrees centigrade. And then I'm going to throw some 450-degree air and try to nail that guy down to the board, and then inspect it, and then make sure that I'm happy with solder job. If not, it'll go right back on the hot board, and we're going to do it again. Not pull the chip off, but refloat it until I kind of like that there's nice little balls along each side. Yeah, like most of the chips you see there look like there's a bunch of balls. That's because the solder's melted and the chip is pushed down and there's a good connection there. And then if I feel like it and have the energy, we'll replace that resistor, and then I can actually go in and eventually test this guy to make sure we got rid of the power problem on this thing. So. Okay, so I'm going to switch views. We're going to actually work a lot in the microscope. First thing you need to do is get this surface cleaned up. So let me I think if I do this, we have a microscope. So I'm going to move the overhead, bring this guy in, and find a position I can work in. There is that pad. Okay, so what I really want to do here is I want to make sure this stuff in the middle is off here, because the chip is going to have some on there. I don't want any of this lifting up and making it hard for these legs to hit onto these solder joints. The other thing I need to watch out for, and like I said, I've been here before, or somebody has, some of these legs go all the way to the base. You need to make sure there's solder resist or paint covering these dudes. So these legs also go clear to the pad. If they're open and you try to solder a chip, all the solder is going to run through that whole leg, and there's not going to be enough to solder the chip down. Okay, so we don't want that. The other thing I do is I just clean this off really well. So I'm going to throw some alcohol on it, just get my target pretty clean here. I gotta have some paper towels somewhere. I use a Q-tip and paper towels. I'm just going to kind of scrub on that, make sure all the old stuff is off. You can see where that resistor is missing right there. All right, so I'm going to clean that off. That feels pretty good. All right, so I'm going to actually take some of the solder off of this dude and just make sure this pad and that pad are clean. So what I do is I get some braided wire here, and I'll cut a little bit off. I don't need much. I'm not going to clean the legs off because I already know I have leaded solder on there. I am going to clean it up. So, all right, so I'm going to throw some of this stuff down, but I use a set of tweezers that I hope I have around. I'm looking. Where are my tweezers that I like to do this with? These are the ones I don't like to do it with, but I might have to do it with. What happens when I clean up my desk for video? Hold on, I'm going to take one more look on this side. Maybe they fell. One sec. Yep, They fell, that's why. I like using a curved set of things. I just hold on to the end. Okay, I also use, before I turn this on, I have this chisel tip. It's really big. And the reason why you want this so big is this guy's made to absorb heat, and so your really fine point on your soldering gun won't heat it enough to clean it off. So you need a big mammoth thing like this. So I'm going to turn this on, and I turn it on about 400 degrees Celsius. I'm going to let it start warming up. Okay, so it's set to 400, it's climbing. The other thing I do with this, I'm kind of turning it sideways because that's how I have to work on it. I have to kind of use one hand this way. In theory, they say you're supposed to like lay it this way if you're going to do the top, and then this is okay, it's just square, but if you were to do the legs, you're supposed to go like with the legs. I don't do that, but sometimes I do cause these problems and have to go back and fix them. This dude's borderline. I see a little bit of solder in there, but as long as it's green for us, if I don't have to do it a second time, it should be good. So I'll try to do that. So one thing I like to do, and one thing you have to do is when you're going to clean the solder off, I don't care if I take some off on the legs. I'm going to redo that next. But I'm just going to put a nice little bath of flux here. It's a lot of flux, but I want to pick up the solder and make it nice and clean. So my soldering iron is 400 degrees. Let's do the base first. Basically, I just kind of scrub it back and forth. And kind of move it around. That filled up with solder. It'll kind of get squeaky clean, if you know what I mean. It's kind of weird. You can feel it. Now the top part, I'm going to go back and forth this way and just clean it out. I can tell it's pretty clean. So let's see if I can get any more. And let it sit there. Okay, and then after that, I just to check my work. I can shine it up. As long as there's not any big amounts of solder, I'm happy with it. As long as there's not those chunks sitting in it, and this is okay too. So I just kind of flatten it out with that point. So good. So I'm going to turn off my soldering iron because we need a different tip next time. And I'm going to clean this guy up. So I'll rotate it back, and let's just clean this up. See what we have here. Now, I spend a lot of time preparing the surface because I'm slow at soldering. This isn't my trade for the daytime. So I have this knife that I got, and you got to be real careful with it, but I really do like kind of just running the blade over the whole thing. You see me taking some up. I don't try to dig in. And I certainly don't go over the legs with this, but it just makes it really nice and smooth if you just kind of clean it up. Okay? Like that dot up here on the top here, that's a little point sticking out. I like to just trim that off. Make sure nothing big is sticking up to stop the chip from sitting down. So of course, if you do this, you want to clean it up because you got a lot of solder kind of laying around. But that feels pretty smooth in general. So, and I can tell it's getting down there. So let me. Okay. There we go. So we've got a clean chip. I know the base is cleaned out, so the chip, when we set down there, is going to clean it out. We really need to fix these legs up. And so let me change my soldering tip. It's a little hot right now, so I use another pair of tweezers to get that off. Hang on. It could be I got to put this on and that marginal solder joint right there goes. If it does, I'm just going to have to stop and we're going to have to repair it. And I can do that tonight too. I've got all the stuff to repair it. So I'm going to lay this nice hot soldering tip somewhere else and get my nice point. Okay, so I was at 400 degrees centigrade just to get that solder off so I could supply enough heat to the pad. But now that I've got my point and I'm actually going to be working with solder, and I'll tell you the temperature of that. I actually bring it down to 300 degrees because I don't want to cook it too bad. So my soldering iron's going to warm up to 300 degrees. And what I'm going to do is I'm going to flux this. I'm going to get some wire solder on the tip, and I'm just going to run this down. And you'll have problems doing this in two places. Where these legs go all the way to the base, it's just a very thin line there. These take a lot longer to warm up than just the regular legs. So when I bring the soldering iron with the solder down, it's probably going to build a bridge here. So I go back later and I just keep working it until I'm happy that this will be ready to prepare a chip. Same thing with this one over here, since that's a bridge off to this one. I do the same thing. This chip socket's well used. It's been abused. Sometimes you take off the chip and they're just beautiful and you don't have to do anything with it. So I half expect we're gonna have to work on that tonight. So all right, so let's do this far one first. I'm just gonna lay a bead of flux down. And I keep the flux pretty handy because once that bridges in that one place, I just keep adding flux. You know, I don't know if you can see this. I know it's hard to focus. I don't think I can. This is 0.02 wire. Chip quick. SMD. And so this is 183-degree melting solder. Okay. So that's what I put the chips on with, is 183. I put the heat sinks on with 138. I think it's 182 or something. But this is a higher melting temperature than the other. So I'm going to actually, let me focus. So I'm going to actually just throw a little bit of this on the tip. Might be too much. So there's some solder sitting on the tip there. And I'm just going to run this guy right on down. And just keep running it down until I get a nice thing. So I've already, if you notice right here, it's already out of the flux. It looks good. I don't have to touch it, but we bridged here. It's out of flux. I'm going to take another run there. I've got too much solder, so what I'm doing now is each time I run this, I clean off my tip. My tip's going to keep picking up just a little more each time. Okay? Until you see actually legs appear out of there. There. Now, I'm going to go ahead and do the other side, then we're going to clean it all off, and I might have to go back and adjust some more stuff. So let's get this guy tinned up. Why it's still a mess, and I can clean it all at once. All right, so we're going to throw a little bit of solder on here. You know, these legs had some solder, so probably too much again, but hey, here goes. Looks like I got some on the pad, and I can fix that. Generally, that's pretty good. These look a little worrisome, but let me just throw some flux. You can never see that very good in the microscope, so I don't know if that's good or not. We'll have to clean it off with alcohol and check it out. So let's do that. Yeah, we'll see. It's hard to tell in a 2D view. So to really get a good view, I tilt, and I'll clean up this mess on the side. Right now you don't want to leave this stuff right here, this flop. You want to get rid of that, and I can probably get rid of it now. Let's do that. I've got my, oh, it fell off. Just a second. Here's my knife. Ah, here's my knife. That's what I use this little X-Acto knife for. As long as you don't dig deep, usually this stuff comes and just pops right off. See, that just popped right off. So we get the other stuff to pop right off. And I want to get rid of that. Definitely don't want it on this main pad. You can't get it to pop off easy. You have to redo the board with the wire mesh. Come on, baby. I saw it loose, so that's loose. Okay, there we go. I think I got it. Really wants to stick on. Okay, that's good. All right. Now, to really see what you're doing, you tilt the board up, and you can kind of look at how the chips. So just by looking at it this way, it looks like I need to add some solder up here. These aren't as high as these guys. So I need to add a little bit of solder here. This guy's a little weak up here. It might be good enough, but I actually might add some solder to him to make him a full leg there. And then this guy is a little weak here. He's okay here, and we got this kind of mess forming. So we may have to repair the board here again. I'm going to flux this up and run it over. Maybe this problem will go away. If it doesn't, I might have to clean this off and go in and fix this board. And we'll do that tonight because that's part of cleaning the board. So what is he? Looks like he has some solder resist on that. But yeah, he's probably not that bad, the one on the upper left. So I need to touch up these. There's hardly any solder on them. And I need to do this. So I really need to run through this guy again. So let's do that. Yeah, look how flat and shiny they look compared to the others. You can tell there's not much solder on them, they're more flat. But that's okay. Then I got this problem down here. Let's see what we can do. Try a little bit less solder. So I'm going to hit the bottom first, see if we can straighten this mess out down here. Maybe. Maybe not. You always want to stay under the flux when you're doing this. I'm afraid there's not enough solder on that guy, so I'm going to have to lay some more on it. And just touch him, get him in flux, and just touch him. Sometimes this goes real smooth, and sometimes these cards give you a hard time. Flux. I don't like how that looks at all. I don't know what's going on there. Might be okay, it's just I don't like how it looks. Alright, so I needed to touch these guys up here with some new solder. I think I'm taking solder away instead of adding it. My tip must have lost it. Replant it. So those are good. I'll wait and clean and see how we did down below there. I just keep repeating this process till this pad is perfect and ready. So I feel something really sharp. It's that guy there. So let's look at this. So down here looks good. We fixed that. These have solder. They're just not great. And these two have solder. So I think we'll be okay because I kind of like that there's not as much solder here because these guys melt last and then go down to here. I'm still worried that this has enough. But let's take a look at it steeper. Yeah, I think it has a good enough reflection. So, all right. Let me see if I can get rid of that sharp point there just to slop solder. Just don't want to keep poking something. Okay. Okay. One last look. We'll review this again. We'll review this again as soon as I get the chip done. I actually lay the chip where the legs are going to go and make sure some imperfections on my soldering job on the chip don't match up with imperfections on the base. And if they do, I'll go back and fix one or the other. And usually I'll fix this because it's easier. Okay, so I'm going to throw this out up there on the heater, and then let's get our, this is the stencil here. And let me see, I usually do it this way. I'm going to put my chip in the stencil. It has this little holder right here. Okay. All right, so I tried using this in the very beginning when I was doing chips, and it was a little bit off. And you have to be careful. You have to adjust this, and it only works one way. So here I just flipped the top upside down, If you notice, there's no gold on the legs; they're kind of offset. You have to adjust this template for this stencil. So I have it adjusted so it goes just right. I have a label that says BM1397 on the left, and that's all I need to do. So this guy's ready to go. So I don't know if I can show you, I have a whole bucket of TS391 AX50 from Chip Clip. It's thermally stable, so I don't have to refrigerate it. It's solder balls, and it melts at 183 degrees. And I have a really nice spreader that looks like really part of what we would call a kitchen knife in the U.S. Let me see if I can show you. And that doesn't really come in. It's just a big old wide dude here. Not perfect, but yeah, I actually think they took a kitchen knife, a cheap kitchen knife, and made these. So anyway, let's put some solder on here. I'm just going to grab a little bit. I want solder left over the top of it when I pull the chip out, so I like to have about double right now what I need. But actually what I do is I get it back and I put it back in here, so I reuse it. As long as it hasn't been sitting out very long. Okay, so here's the mess of solder. I'm just going to start kind of pushing it in. And I kind of do it from 4 directions. And then I leave a little bit on top, like this. I kind of cover it up, okay? All right. Now, I'm going to set this aside. I still have my jug. I get a needle, just a stupid safety pin, and I go find one of the holes on the chips, preferably on the base. I think I've got one right there. And I push that on when I'm lifting this up. And you'll watch, it'll pull away. You'll want the chip coming up. So now with it not very high, I just poke a few more, making sure that chip went down, okay? So I think the chip is still in its socket. Voila. Okay, so there it is. So before I do anything with the chip, I'm going to clean up my mess. I'm going to scrape the excess solder off my stencil and put it back in my bucket of solder paste. Stuff's not cheap. And really kind of watch what I do with it. Okay, so that's not a perfect clean. I still need to get alcohol, and I do this right now even before I handle the chip. So I've got this knife, cutting knife. I take a small paper towel and I make sure this solder is bad stuff. The solder paste is even worse. Like if you go eat lunch after this or something, you got it all over your fingers. So I'm really pretty careful. I use a paper towel, I wipe it up, and I toss the paper towel. So my squeegee is good. And now what I'm going to do is take another part of the paper towel and clean the rest of this with alcohol. And it'll be ready to use next time, and I don't have to worry about it. So I do this before I heat up the chip, for sure. Okay, so we are all clean. I think I have a drop of alcohol in there. So that's good, it's ready to put away. I'll throw away that little piece of napkin. Now, let's heat up the chip. So you have a choice, just so you don't make this mistake that I did. You have a choice of, you know, if you get tweezer sets of these nice small things holding the chip, those fall out really easy. So I use my, if I can find them. Yeah, do that. I use my kind of mammoth thing. Now I'm going to set my heat. Turn off that heat. I'm going to set my heat for 300 degrees on the hot air gun. And I'm also going to turn the air down. Alright, so I've got 300 degrees on the hot air gun. Let me pick this chip up. And here we go. Got the air down. I'm going to melt this solder. Wish I could show it. I just don't want to cook my heat up my desk. There we go. You see it change over? Okay, so that's a nice shiny chip now. So I'll put the gun away. I don't want the chip to stick to my table. Let it cool off here. Alright, I'm going to put my stencil away. I think we did our job. It looks like I have... We'll look at this. I'm going to wipe this in alcohol first. All right, here we are. The way I look at the job we do, I actually pick it up, hold it in my hand, and I will look at the legs for uniformity. And these are okay, they're not great. These are better, more what I usually expect. Let's check out the other side. I want to make sure I don't have any work to do here. So if you get a non-perfect thing, so what I call non-perfect, these are 10. If you see right here, there's just hardly any solder there. I want legs to stick out. So my my push on the squeegees for those two legs, I think, get closer with them. Oh, they're sticking out. Okay, I'll accept those. If those were flat, I would not accept those. And I literally go get solder on the head of a pin, solder paste, and put a little on the chip. I'd actually bring the chip in here. It turns out those have enough solder. But I'd get a little solder paste on the head of a pin, and I would spread it here, and I'd reheat it. And if I actually formed a bridge, I would flux this up and just run my 300-degree iron really fast over it, and it would create this really nice set of pins over here. So anyway, this chip is ready to go. So let me bring the board back. Let me put away my stencil and my spreader. Comes the board. Don't lose your chip while you're moving stuff around. Okay, so here we are. All right. So here's what we got. We're going to put, if you turn the chip over like it's supposed to, these are the legs that are going to touch those legs. And so I've got that mess in the lower quadrant down here. I think we're going to be okay. I think the chip's legs are fine. So then I actually look at it on the other side and match it up and say, what do I got going on here? It appears that I'm in pretty good shape with this chip. Okay? So let's go. Any questions before I move on? And I'll watch. You guys are certainly able to ask questions. I'll stop and answer them. Okay. I've had various renditions of putting on chips before. Sharp stuff here. The problem is if you don't get it exactly level on the where this board is on the heater, when this chip heats up, gravity will take place and it'll just fall off. It'll just slide off halfway, and then you're kind of hosed. You basically have to pull the chip off, re-prepare all the surfaces, fix the chip legs, and start over again. I don't even try to force it. So this is kind of an important step to do right. I don't put much flux here. I put a little bit of flux here. I want to get that hair off there. Hair would be not very much fun on the solder. So I put it I start a little bit of tiny flux. That's a lot of flux. So I just kind of spread it around. And the same thing on the legs. I don't put much. I make sure every leg has access to the flux. And every leg here. I don't want the chip to fly off. I don't want the chip to boil it off. I want the chip to grab a hold and hold on to the solder. It could be that I have to do this twice. I prefer that instead of a missed. If the chip slides off, basically I have to start over. And I'll, who knows, I might restart the video then, I don't know, but we'll see. Okay, so now, to place this guy, you see some people moving chips around while they're floating and the chip kind of sticks. I don't do that this way. I found that if the legs get over the pad steals the solder off the legs and then you don't have a good chip. So I really try to place this right the first time. So if you see this mark, this is like a corner up here, and this mark is a corner, and then I've got this mark as a corner, and I do want to clean up so I can see it, that corner. That's going to be really my guiding, that line and that line, and I'll try to center the chip that way. So make sure you're going to put the chip the right way, small on the small and large on the pad. So I just kind of get as close as I can with my finger. And then I take my curved pair of pointers and I just start barely working it, bringing it up to those lines. That's pretty close. I just need to go up a little bit, right? Look at that. Now, it looks like on this side, no, I think it's there. I can't quite tell here. It almost looks like we might need to touch it over here, but there's flux, so it's hiding it. So I really don't think so. I think that's going to work. Maybe a touch. Let's see if I can just nudge it to the left just a little bit. It'll probably nudge back when I heat it. Okay, it looks like it dropped a little bit, so I'm going to take this corner and bring it up just a touch. Okay, I'm actually holding onto those tweezers. Hey Jeff, how are you? I'm holding those tweezers with two hands so I could just be gentle. And don't get stressed out. Many times I've knocked it, it flies off the board, I have to start over. So I'm going to be real careful with this. It's really just sitting on flux. So the points I want to make out when I set this here, I'm not going to move it. It's going to heat up and in theory drop down onto those things. I make sure the left and the right, you can actually see the equal number of chips so you're not off to one side. Okay. I look at the corners of those lines to make sure we're pretty good on that. Then I look at the chip and I look at the last pin. So you see the last pin right there and the last pin up here. This helps you adjust it up or down along this line. Both those should be kind of the equal distance. One shouldn't be right up near the edge and then one shouldn't have a bunch of space at the top. Okay, so this chip is really good. Now the game is I got to try to heat it up without it moving. And that's always hard. So I do all sorts of balancing trips. I have the end up on the heat sinks and do that. So I'm going to switch to my other camera. We're kind of done here, except we're going to heat up the bottom and cook it for a while, for about 10 or 15 minutes, maybe 10, really. I just need to get it hot. Then I'm going to cook it with the air gun. We're going to pull it back off, set it right down here, look at a microscope, see what kind of soldering job we did, and if it needs another round. And what I look for is either, well, I'll move it easy. If you look at this chip, see those nice balls? That's what I like to see. It should look something like that. You should not see kind of unmelted solder legs sticking out. When I see an unmelted solder leg sticking out, chances are you don't have a good soldering job. So I actually go back in, heat it all up again with more flux this time because it's not going to move. And I apply some really, let's just say significant pressure with these dudes. Like if this corner of the chip was legs and the rest was good, I'd actually heat it up and really pretty firm pressure down like this, then heat it up after I push it to do it. Okay, so now let me go over the heating process with you. I'm going to put this on the hot plate. I probably should now, but I always design the hot plate so that I can set my arm somewhere because I use my right hand to push this down. I use my left hand to hold the heat gun. So map it out. Don't get up there and be surprised like the heat gun hits the camera like I don't want it to happen or something like that. So map it out so that you know where your hands are going to go and you feel comfortable and you feel steady with your hands. Many times when I go to push down this chip in the end, I slip and I throw the chip off. It's really frustrating. I just kind of accept it as once in a while I do that and I'm going to have to do it again. So I pull the chip off and I do it again. So you just got to be patient with this stuff because my hands shake. And so I got to deal with that. They don't shake like this or anything, but I'm just not a brain surgeon. So, all right, so we're going to do that. I'm going to heat it up. What will happen is you'll see these things start to sparkle, either the legs, and that's them melting and actually getting into a molten state. And then sometimes you'll actually see the chip just drop down. And it's weird, it'll just go bloop, drop down. And when I see it do that, I know that the chip is melted on the base, and I know it's melted on the legs. And then I kind of move in with this, and I just push it down, and I heat it a little bit more. And I watch those legs, the legs come out in the balls, and then I pull off the heat, and then I bring it down and inspect it and get ready to do it again. So here we go. I'm going to switch cameras on you. Okay, this is my rework station. I'm going to flip the camera up. It's got a hot plate, and the heat gun's right here. My plan is my hand. Let me get high because we're going to have to get high. So my plan is I make room for my hand on the chip right here, and then the heat gun's over there, basically. So Let's go ahead and go a little higher. And then position it. Okay, so you can't see the settings, but I'm going to actually, so I'm going to set the board on there. And this is kind of in there. I usually like it when the other way because the chips are right there. So I'm going to have to do a pretty good reach in there. So I'm going to set the board where I know I can reach it. I know where the heat gun can get to it. So about right there. The only problem is this is hanging off the front, and see how it rocks like that? So what I do is I get 3 heat sinks. It just so happens that if I put 3 heat sinks down there, and I put it on the base heat sinks, and by the way, I do have all the heat sinks on, but it actually really stabilizes the board. See, I'm tapping on it now, no rocking. Okay, so I'm going to turn on the hot plate. It's set for 181 degrees centigrade. It won't get that hot, but I will heat it up to 140, 150. I just kind of let it cook there, and it stops your chip from exploding while you're trying to heat it too fast. So. You see, I'll move the microscope right now out of the way, and then I sit and I kind of watch it. The way my light is situated, I can actually see a reflection of the legs here and a reflection of the legs here, and they're shining back at me, so I know the chip hasn't moved. And if the chip moves, I'll know it because that reflection will disappear. I'll see if I can. Maybe I could zoom in. I could try. I don't know if I zoom in. I don't know if I can go back out. But let me focus a little better. Oh, there's a delay. Hang on. So it's about the best I'm going to get. Okay. Anyway. All right. So it's a big waiting game now. I have to wait about 8 minutes, 9 minutes, 10 minutes. And on live video, you can't pause it. So, anybody have any questions on anything? I'm here. I'll answer them. There's a lot of people on Discord that have a lot of good answers too. So, I think you guys probably were on Discord because I announced it. So. I'll get my drink of water. So this is my heat gun temp, and I do have to have it ready, so I turn down that. I literally bump this dude up to at least 450, maybe 455. Not 460, probably. So I leave it about there. And when I pick it up, it'll start to get warm, and I remember to keep the fan down. Things are going to get hot, the resistors are loose, you don't want to stress the board out. Do I have a hot plate? Yeah, well, Robin, thank you for the question. The question is, do you have to use a hot plate? So I used to try to replace these without it, and my success rate was low. I had success. I had more success with used chips than new chips, but this was revolutionary. You need a hot plate. If you're going to replace these chips, the BM1397s, you need a hot plate. I'm not sure about the 1387s like on S9s and stuff. You know, there's movies like from Zeus that they show them doing it. I just don't. I've never done it that way. I'm getting ready to do an S9, so I'm going to find out. So, oh, both. Thanks, Brian. So Robin, if you're going to be doing a chip, get a hot plate. And remember, the reason I'm using the heat sinks on the bottom of this board to help me heat the whole board. Don't take the heat sinks off the bottom of the board. When I used to do the chips, I'd have to remove the heat sinks because I didn't want anybody absorbing the heat that I'm applying to the chip. But this is far better. I used to blow up chips once in a while because sometimes it just wouldn't go on. I've never blown up a chip since I've used a hot plate. And also they just go on so much easier. You get some really sweet solder jobs like these nice bubbles, where the other ones were kind of precarious. Like I said, I had better luck with it. Listen, do I have a gear set list? I do. I bought this on Amazon, and I put a link in the tools and supplies, but unfortunately Discord scrolls up. So Let me see. And I don't have the right PC. I have it. I'll tell you what I'll do. I'll go back around to the Discord link on the live chat area, which I don't watch anymore because I'm using YouTube chat, and I'll throw my list in there for you guys. It's mostly solder, and I think it is the rework station. There's a couple things I don't have, and I'm really thinking about putting together a series of videos with the equipment that you need, because there's kind of two levels of board work. I can't imagine buying a miner and not being able to put back on a heat sink because it's so common, like in shipping, if they fall off. So I'd like to just do a set of videos on cleaning, finding solder balls, the equipment you need to do that, because it's not that much. You can buy a $59 soldering heat gun, some tweezers, and a digital microscope, probably for 200 bucks, and maintain a lot of stuff and fix some stuff. So thanks, Webmaster. I appreciate that. So I'd like to do that. And that's for people that are kind of small operators that really don't want to get into this. This has taken me a while to learn. It's just you don't do it overnight. And I'm trying to give you guys the educational stuff so that you can learn how to do this, because frankly, I didn't know how to do this last year. And I just decided I didn't want to be so dependent on repair shops that were 6 months back. How do you keep a mine board productive when it's down for 6 months because you're waiting for it to get fixed? By then you can learn how to do it, so you just well learn how to do it. I do have a microscope now. I used to do it by hand with a digital microscope, but I love the microscope now, especially since I'm doing videos. I guess Louis Rossmann has something like this. I kind of looked at his microscope, got what he did, kind of modified it a little bit for mine. I got a camera. I actually have a computer monitor that I work under the microscope. I don't put my eyes on it at all. So I actually watch it on a screen while I'm doing it. And it took a while to get used to, but I got used to it. Let's see how we're doing here. So chip hasn't moved. I'm starting to feel some heat. Someone told me last time I need to get infra again. So we're pretty warm. I'll just wait another minute or two. And then let's do this thing. Ah, LED stuff. Wow. So that's an interesting thing, because I keep, I start searching for these chips that are on the question is, Brian says he needs to repair his ASICs as well as LED modules for video walls. And the reason I'm repeating questions is in case someone doesn't have the chat when they're watching this. But so I notice I keep running into the LED modules have a lot of these voltage regulator or voltage translation stuff. It's kind of interesting what powers them. So you're going to get really good with power and do that. And I don't know if you do this, Brian, but I actually find the chips that are on there and I go to and get their data sheet, and I try to learn from the data sheets what the manufacturer's designing them, because it'll say, oh, if you enable this, it'll do this, or if you put these resistors on the end, it'll actually feed it back and change it. And I don't know everything that they're saying. They have all sorts of graphs that I don't quite get. I'd have to be a electrical engineer to really want that stuff. But it's really helped me to learn, understand what the chip's doing. So yeah, you're gonna get good, because I bet LED modules break down a lot. Okay, let me get a drink of water and maybe we'll do this. This is always a scary time, especially on live video. And frankly, if I mess it up and it goes sideways, what I'll do, I'll talk to you guys a little more, take it off, and then next time I work, I'll pull it back off, re-prepare it, reseat it, and just go on with my life. It's just, I only do one of these a night. I work during the day, so yeah. Okay, so we're going to be flipping around between the overhead and the microscope. So as soon as I seat this, my guess is my first seat will leave some legs out, not melted, but I want to identify them and know where to apply the pressure. So we're going to go get the chip stuck down, then I'll really put flux on it, for sure. So from what I can tell, I see the nice legs. But I don't see the legs where we had that double thing going in where I had problems, but that's okay. These are nice and shiny on the left, so I think the board is really warm. So let me get ready. What is the balancing act? Now I'm probably going to cover you up a little bit on this, maybe not. I'm going to be right up. Remove the microscope. You might be able to see something, you might not. My fingers get hot too. So, all right, so here goes, guys. I got 450 degree air turned on low. Hopefully you can see something. I'm waiting for those legs to twinkle. And I'm waiting for that chip to fall down in there because it just did. So the board was really hot. So literally, that's all I need to heat it up. But I'm going to push it now. I moved it a little bit when I pushed it, so hope I didn't screw it up. So I'm holding it down and still soldering it. And I'm a little bit worried about, I pulled it toward my side. So I'm holding it, I put the heat iron off. I'm just letting it cool off. Okay. So I did pull it. When I put it down, I pulled it this way, but I still see legs, so we're going to be okay. So while I still have the heater on and everything, and burn yourself, let me get this up and I'll switch camera sources. And I'll show you what I mean. All right. Okay, wait a minute. Okay. So let's get in there and look. So really I don't have this melted very much, but I have it stuck down. Did I move it much? Yeah, when I popped it down, do you see this? I don't want it to cool off, but it's a little bit crooked. I think it's good enough though because we haven't trimmed off those legs. But this guy's a little bit precarious here. He's a little close to the edge there. See, I'm showing the base here. This guy's not good. So when I moved it and put it down, I messed it up. But what I'm going to try to do tonight is heat this guy back up and try to move it back. I've had success doing that. I just don't usually do it. But since we're on video, let me go do it. So I'm going to pop her back on the hot plate. And this time I'll use a lot more flux. I'm going to switch. Hold on. Okay. So the chip went this way when I put it down. It kind of twisted this way. So I'm going to actually grab it. I'm just going to bring it around. Sometimes I screw it up worse, sometimes it works. So this time around, I'm going to flux it really well. So the solder stays where it's supposed to. Okay? Well, let it sit just for a second, then we're going to heat it. And we're going to go. Ah, you are. Brian, that's great. He's an electrical engineer. And I wasn't a video engineer. We did a lot of video production. I did some. All right. So let's try this puppy. We're not that far off. Let me get my hand in here. Microscope's in the way a little bit. All right. See if I can just nudge that chip back. Usually I can't because my hand's not steady enough. I'm going to wait till these guys start twinkling again. This side solder is starting to melt, which is normal because it's been a lot of heat. I see the legs on that side. Let me see if I can barely do this. I think I did it. Hard to tell because I can't see. All right, so everything's kind of going here. I'm going to push down. My chemicals off. We'll see what I did. If I have to, I'll just start over. Usually I heat it for even a little bit longer. Okay. All right, let's take a look at it. Looking better, from what I can tell by my eyes. Okay, switch camera. Okay. You see how I got the balls there now? Oh, good, Robin. Cool deal. Man, I'd love to talk to you about some plenums. I have a cardboard box plenum. I'm going to make some stuff, but we'll have to have that discussion later. So this chip isn't good right now, guys. I'll tell you right now. But I want to tell you how to recognize it's not good. So this side is really nice. See those nice balls there, how that was? That's what both sides are supposed to look like, and that's what I usually get. I got a problem over here. These guys right here, the solder got lost up in there. Now what I might do is try one more time, and I think I will, and just try to apply pressure here, and it might push the solder right back out. So I will try that while I'm on video tonight. If I'm not successful, I'll pull this chip and I'll recondition it again. I was successful at straightening it out, but who knows what damage I did by doing that when I had to straighten it out. It looks like I shorted the corner here and moved it kind of the corner this way a little bit, but these look okay. Looks okay till you get to this last quarter of the chip. So let's heat it up, and let me see if I can get this guy seated. And then if I can't, I'm going to call this chip, no good, I'm going to switch cameras here, guys. I'm going to call this chip a rework one. I'll have to do it again. It really doesn't upset me, but let me see, that didn't work. Still getting used to this OBS. All right, we still have the 181 degrees on it. This flux is kind of sticky on this because I just heated it up, but I've been successful. I just add some more in there. I mean, I really just literally make a mess, but that's okay. So now the plan here is I'm going to heat it up, and I'm on this side of the chip, on this back corner of the chip. On this corner of the chip is where we're going to concentrate. Hopefully I can get it to take. Keep my hands cool. Let me just get that heater going a little bit. And it says, okay, it's 181. I'm going to move back to the microscope so I can get a better take now, because it's going to take. All right, last try on this guy. Everything's still warm, so it takes a lot less time to rework. But I'm going to work on this back corner in a sec. Get it nice and warm. I'm watching those legs. You can tell when they start to melt. To draw that solder out of the side, it's going to take a little bit of heat. So. All right, this sec. Again, my best friend's flux. Okay. So here goes. I'm going to get right on the edge of this dude. Bring her down. Okay. I learned this technique off of another guy that does similar chips. Now I got a problem, so I applied pressure here. If there was some unmelted solder, it could flip my chip up. So it could be that I still need to go back in the center. We'll see. We'll see if I found the solder there. Looks like I might have. Second, I'm lining up there. Getting so thick with solder that, yeah, it looks like I found it. Hold on, I'm switching the camera. Okay. So there's that side. Still looks kind of interesting, but it looks like I was successful here. Remember, that was scrappy anyway. And it looks like I've got some nice balls here. So this is what either side, let's make sure we didn't screw up the other side. The other side, what on earth is that? Unless I messed up the chip. Just dirty flux. Okay, never mind. So this side is good. So it looks like I was successful. We'll measure it. Literally, I'll start to measure it. So I'll switch back. I'm going to let it cool a little bit. Then I'm going to throw some alcohol on it. I'm going to clean this puppy. I clean as much as I can. And literally, what I'll end up doing, and I think I can do it some here, but the flux reflex, I turn the chip up on its side. And I really start looking closely at what I did for solder. It may look like it's balled up. Like, check this out. Hold on. This looks like it's balled up right there. But it almost looks like there's space between the chip there and it looks just like a solder leg. Now I do think actually it's melted and sealed, but you can tell a lot by turning the chip up and looking at it really close. This over here, and I can't do it again because the board moved. Let me see if I can move it now. I mean, it did get pushed out. Right here. It did get pushed out, but literally some of these are just balls and they don't look like that. But I think it looks pretty good. Let's measure it and see. I'll show you my checks that I do on my chips. So I'm going to flip the camera again to... Okay. I'm going to move it around here. Hang on. I've got a very small workspace. Okay. So this is the chip right there. Let me get this. Now I've got a video on diode resistance. That's really what I use. Right now the chip's hot. If you try to measure, I'm going to turn that hot plate off by the way. If you try to measure regular resistance, it's going to show where it shouldn't show. So don't measure regular resistance until it's absolutely cool. So I get the diode by pressing this twice. You see diode up here. And it'll be lower than it's supposed to, but they should be equivalent. One's going to be higher because I'm missing a resistor. We'll see that. Watch this. So through this flux, I got to find the actual ground on the chip. Let's see. Hopefully you can see that. 1086 is good. Should be close to the other side. Now the other side isn't good because the resistor though, so it's going to be higher, but I'm okay with that. 10. This will be lower because it's the middle RO port. Wait a minute. But that's bad. I'll explain why in a second. So all these 1093s and stuff around the same should actually match this stuff. 11, it warmed up a little bit, so it's coming up, cooled off. 1099. The middle one's always lower. 0.3, that's in line. 10, and then 11. So this side of the chip got soldered good. This side of the chip, although I have to go check it out before I really tell you definitively. But this reading with diode resistance, so this is the RO port, 0.025. Wait a minute, let me get it in there. That's really low. So this guy is shorted to something, and that guy's no good. So I know that my chip thing didn't do too well. The rest of them probably would check out and pass voltage. This guy, so maybe we'll need to explore that. Let's go take a look at that. One thing could be that solder got over here and actually bridged against something. I'm not going to be able to know that until I clean it. Geez, this chip is just problematic. Usually they go on and I got it. Sometimes even the first time. But let's go have a look at it here. It's still hot, so I'm kind of be gentle around this. Let me get all this flux off. It's all around. The alcohol absorbs the flux, and then when I put it in the paper towel absorbs the flux, so it actually removes it pretty nice, which is kind of neat. Alright. So probably when I moved the chip, I broke the line, and what I may do is I may put it back on the hot plate and apply pressure back over on the side it needs. We'll see, because the rest of the chip seated pretty good. All right, let's take a look in there. Go back here, bring the microscope in, and then I'll switch camera sources. Yeah, okay, hang on. Okay. So now, if you look at this, with the flux off, These look like unmelted legs. You see this? So it could be that I picked up this chip when I applied pressure to these guys to get the balls over here. So I actually think I'm going to go back and I'm going to melt this and I'm going to put this chip down again. Okay, I've got it cleaned up. I can hit it with flux. It should be good. I don't usually have to work on chips this much. I usually have to do twice. Let me do this. We're going to try it. It's better than pulling it off and reworking it. So this is going to be the record long chip change. Brian, when you went to school for electronic engineer, how much soldering did they teach you? I'm kind of curious. I work at a university. I'm kind of thinking about walking over there. If you're still on. I know this is getting long. Hopefully it's keeping interesting for you. I'm just letting this heat up a little bit. We're at 150 before I shoot it. All right. Speed this on a little bit. Remember, there's no flux because I cleaned it all off. So. About a semester, cool. Oh, interesting. I can go take classes at the university. And I've been computer science mathematics all my life, but I'm thinking about seeing what they teach. They probably have some pretty cool equipment to use over there. So I let it cool off when I put, I let it cool off pretty good when I put that alcohol on. It pretty well shocked it into existence. So I'm really going to spend a little bit more time and let it heat up again. Sorry for the delay, but I'd like to get that other part of the chip down. And if I can't do it, like, don't ever be afraid to say, I've gone too far in, I've moved this thing around too much, it's not going to work. But I did check the resistance levels on the diode, they look good. I think we just floated one side of it up. So I'm going to give it a good shot of heat again, so I can get everything nice and flowing in there, and then firmly do it. This time around, because I've made connection with the right side of the chip, I can actually push down on the middle of the chip in uniform. Everybody should be pretty connected. So I'll probably do mid to, and I know it's hard for you to see, but probably a little bit on this side over here, but more toward the middle, not just on the edge, so it applies pressure on the right. Yeah, it's getting there. A couple more minutes. Okay, let's see how we do. I'm going to actually, because flux helps heat transfer, I want the middle of the chip on the base plate to melt, because that's what's going to give me the room and not let it rock back and forth. So that's what I'm after, and then when I push down, everybody should be happy. So here we go. Move the microscope around just a touch. All right. I guess you guys can kind of see that. I wish you could see that close. Heating it up. See, just that flip of the wrist, when I put it down the first time, it was perfectly aligned. And then I went to push it down and I pulled it toward me. Caused all this. You guys with a steadier hand are going to be good. So I'm going to, I'm not seeing the legs do what I want yet. So I'm going to just make sure they have enough on the side. Yeah, there they go. Okay, here we go. Choose your place wisely here. Okay? Okay, this will be the last try for tonight. Otherwise, this will be a marathon session, because really what I have to do is start over again, pull it off, clean off the chip. Let's have a look. See how we did. And I'll switch over to, did I find the chip on the microphone? On the, where are you? Well, it looks good. What do you guys think? Here comes. There it is. I guess the telltale sign's the resistance, right? I don't think we did any damage on this side. This is maybe, but doubtful. So let's do the last measurement, and then I'll know if I have to pull this chip off again. So I'm going to pull this off, flip the camera, you can see me measure this. Okay. It's still really hot. Okay, the chip is here. Let's get the voltmeter. It's still set for diode resistance. What we're looking for is a decent number and not basically a short. So find it on the chip. So these are right. Here goes. That is a more correct number. See, it was 0.028. Now we're 0.3. So I'm not sure this is right yet, to tell you the truth. This should be reading probably 0.4, and it'll go up to 0.7 on this middle RO port, but I'm going to try it. It certainly improved it. We moved something around in there for sure. I'm going to turn that off. So this is still suspect. What I'll probably do is take it off. I won't take it off. I'll go test it. I'm going to wait for it to cool off. I'll clean it up. I'm going to go test it. If it's not passing the voltage, it's not. Let me check the regular resistance of those power lines too. So if I can do that so you guys can see it. So one should be about 1.5 and the other one should be high. This is the 1.5 one. Yeah. That pretty well tells the story there, right? Oh, actually, it's not fair for me to measure it now because they're hot. So, yeah, I have to wait until it cools down. I'm sorry. If you're doing regular resistance while things are hot, you just won't get a good reading, period. So they have to cool off. So, all right, well, I'm sorry. It just wasn't clean, and I look like everything's perfect. It never is. But hopefully the way I showed you to do it, and that process has worked for me like many times now, like at least 30, 40. So what's the RO on a good chip? Oh, let's look. If you consider this board a good chip, so the RO with diode resistance, good question, thank you. The RO with diode resistance on the ends are different. They're usually lower. So the RO out on the ends should be in the 400s, like that. That's pretty normal. But as soon as you go on the bridge to the inner chip, they should go like to 700, sometimes 800. Okay, so here's 678. So this board, every board has its personality. So probably I could measure all these, like they might all be 678. Yeah, so here this one is. That's the nature of this board. So whenever you do these, don't like pick up the sheet and say this should be 1.2 or 1200. It isn't. You have to measure all the boards. Some of them run 1180, some of them run 1150, and they still work. So get to know your board and then compare it. So given that this is 600, I still don't think it's going to come that high. I could be wrong. Yeah, I think it's going to stay low, but we'll see when I test it. So that's how I keep, if it was just marginal, I hadn't put it in so many times, I'd probably throw it in again and say, oh, that's not good. I use this diode resistance while the chip is hot. It doesn't measure up to what it's supposed to be when it's cool, but as long as the two outsides are pretty conformant, there's when I say two outsides, you got five things, ROs in the middle. As long as the two outsides are pretty close, one of the outsides is always lower, I know that just by experience. As long as they're all consistent on both sides of the chip, you've got a pretty good thing, a pretty good mix. If you ever see 0.002 or 0.003, it's really low, and it's not going to be good. It just won't be. That's how you find a bad chip. So if that's not good enough, I'm going to get a 0 ASICs problem. You'll see that. You can find 0 ASICs problems by measuring the diode resistance, and you get 0.002 on something, or the resistance on these guys here aren't good. That'll cause a 0 ASIC issue a lot of times, which is kind of interesting because it stops the power from going through. So, yeah. So all I'll do now, just to show you what I'll do next, it's a little bit different process. I'll pull this off if it's no good after I test it. And I won't test it like in a full tester like this because we don't have heat sinks. I'll actually run the voltage setting on the meter on this while I'm testing it. And if I see the voltage go through like clock, it should be 0.8, 0.9, sometimes it's 1.1 if you got some really old LDOs. But I'll sit there and measure the clock circuit on this. And if it's showing 0.8, 0.9, and it does that for 5 or 6 or 7 seconds, it means the chip's running and the thing's going to go try to hash on the tester. So I shut it off immediately. I don't let it apply voltage to the chips very long, for sure. And I never test it without these dudes on the back to absorb heat. Looks like I lost one up on the stove up there. I'll have to put it back. No big deal. So I'll check this that way. And if it starts to hash or starts to get past the finding ASIC part and it's happy, I'll put all the heat sinks on and go for it. If it doesn't and I get bad voltages or I get bad resistances here, I'll pull the chip off. And this chip already has tin on it, but some of it's going to be weird. So I'll actually go in there with a needle and I'll brush it up and fix it up. I'll spend some time on the chip and actually do what the stencil would have done again on a new chip and reuse this chip on this board. And I'll also prepare the board just like we did. It just is a repeating process over and over. I think the worst one I've had to do is 3 or 4 times. It gets really old. So, sometimes these sockets, the chip always wants to go off to one side. This one's not that bad. It was me that did the problem on this. So this is my hand. So guys, thank you. I appreciate you watching. I appreciate the questions. Don't be afraid to do this. I will post some of my equipment that I have. I think the rework station and the solder I use is the list I add. And give me a day. Give me till tomorrow to do that. I'll post it where I posted the live broadcast on the Discord channel. If you tuned in and you're not a subscriber, please hit that button for me because I need your help for YouTube. I'm going to make this monetization thing. I don't know what that means yet. Probably 10 cents a day, but I'll take it, I guess. So, any last questions before I sign off? I got to clean this up, but you guys don't need to watch me clean this up. Okay. I'm going to sign off now. Oh, keep it up. Oh, thank you, Ollie. I appreciate that. Nice having you on. Look forward to talking to you guys in Discord.